Imagine you walk into a room where the walls rewrite themselves every time you look away. Words shift, images rearrange. The story changes depending on how you read it. Strange. Maybe. But that's how your memory actually works. Your brain isn't a storage device. It's a storyteller, constantly rewriting the script of your past. Today, we're entering that room. And once you understand how it works, you'll know exactly how to learn faster, remember longer, and think clearer. Let's start with the moment your brain learns something deeply, the kind of learning that actually sticks. Not passive reading, not highlighting, not just listening. Those things create a first weak trace. Like walking through a city once, you kind of know the streets, but the memory is fragile. But deeper learning begins when your brain takes a guess, checks reality, and discovers even a tiny mismatch. Here is an example. You're learning a new language. You think a certain word works one way, then you check and see it's different. That tiny moment of, oh right, imprints the correct form much stronger than if you had simply read it. This is called a prediction error, and it opens a short window where the brain becomes flexible, ready to update. And once that window opens, something interesting happens next. Your brain doesn't just correct the mistake, it starts rebuilding the memory itself. Think about remembering a childhood friend. You don't retrieve a saved image. Your brain reconstructs his face, his voice, the place you met him, all assembled on the spot. Each act of remembering is a reconstruction. The memory strengthens. The details shift slightly. The story updates. That's why explaining something aloud, even to an empty room, creates far stronger learning than just rereading the same paragraph. It forces reconstruction, not passive exposure. Now let's talk about something people misunderstand all the time. Why we forget. When you forget something, it's often not deleted. It's just hard to reach. You see someone from school years ago. Her name? Gone. Then suddenly, later that day, boom, it comes back. The memory wasn't deleted. The path was blocked, then reopened. Now let's talk about another piece of the puzzle, the part your brain cares about most. Details fade first. The structure tends to stay. Your brain is a master of compression. Over time, details are usually the first to fade, but meaning, the structure, tends to survive longer. Focus on understanding the concept, not memorizing the noise. Think about watching a movie years ago. You may not remember every line or scene, but you remember the theme, the feeling it gave you, the main conflict, the lesson. Chapter 2. Why learning sometimes feels impossible. Your brain doesn't struggle with complexity. It struggles with confusion. You open a tutorial. The teacher starts with formulas, unexplained terms, tiny text, no examples. Your brain isn't overwhelmed by the topic. It's overwhelmed by the presentation. When you remove that confusion, when the explanation is clear, the structure is simple, and the steps make sense, the topic suddenly feels much easier. Once your brain isn't fighting chaos, real learning finally begins. The preview effect. When you jump into something completely new, a dense lecture, a complicated chapter, or an unfamiliar concept, your brain is hit with details it can't connect to anything. It's like trying to understand a story while missing the first 3 chapters. Without even a tiny bit of context, everything feels heavier, messier, and harder to follow. Your brain can't predict what's coming next, so it can't make sense of what you're seeing. That's why new material often feels overwhelming, not because you're incapable, but because your brain is searching for a starting point. Another reason learning feels hard is that your brain doesn't treat all information equally. It prioritizes what feels meaningful, interesting, or surprising, and that "this matters" signal makes memories more likely to stick. That's why emotionally charged moments can feel unforgettable. Think about how hard it is to memorize a paragraph for a test, yet you effortlessly remember a conversation that made you angry 5 years ago. Your brain isn't broken, it's selective. Chapter 3. Now that we understand how memory actually works, how it builds, rebuilds, and strengthens itself, we can finally use those same mechanisms to learn faster. What comes next isn't a list of hacks. It's using your biology the way it was designed. Predict before you study. Before reading a chapter, guess what it's about. Before solving a problem, predict the answer. Even a wrong guess pushes your brain into active mode. It starts searching, connecting, and preparing to update the idea. This tiny step transforms studying from passive intake into real learning. Recall, don't review. After you read something, close the book. Explain the idea out loud, as if you were teaching it to someone. Then write it down from memory without checking anything. Because when you try to recall something without looking, your brain has to rebuild the idea from scratch. And that effort is exactly what strengthens the memory. Space it out. Study in waves, not marathons. Do short, focused sessions. Take a break, then return. Every break forces your brain to pick the path up again, rebuild it, and make it stronger than before. Reduce friction. Clear notes. Simple explanations. One task at a time. Think of it this way. Before you start learning, clear the mental clutter, remove distractions, choose one clear source, and make sure what you're looking at is easy to follow. Learn through examples. Your brain detects patterns through variation. The more angles it sees, the deeper the concept sinks. So when you study something new, don't rely on a single example. Look at different versions of the same idea. Different problems, different situations, different contexts. Each variation gives your brain another piece of the pattern, making the concept clearer and easier to recall. Build the map first. Start with structure, then attach details. Think of it like building a house. First you raise the frame, the big ideas, and only then do you add the smaller parts. This mirrors how memory naturally organizes information. And finally, one of the most important parts of learning that most people overlook is sleep. Sleep is one of the brain's main consolidation periods. It strengthens some connections, trims others, and helps organize what you learned so it's easier to find later. In simple terms, sleep is when your brain actually saves the progress. When you cut sleep short, new learning tends to stay more fragile, easier to lose. That's why even one good night of sleep can suddenly make something feel clearer, while a sleepless night can make yesterday's learning fade like it never happened. Memory isn't something you store. It's something you rewrite. A living system. A flexible map. If you work with this system instead of against it, using prediction, recall, spacing, examples, and rest, you don't just learn faster. You learn the way the brain was designed to learn. And when you do that, learning stops feeling slow, confusing, or exhausting. It becomes natural. That's how it finally starts to work.